Okay, next topic is we're going to count how many subsets there are of a given set. We're going to start with a really tiny set and figure out how many subsets there are of this set. And then we're going to try and look at a slightly larger set. And then we're going to try to make a generalization about how many subsets any given set would have. So the set that we're going to analyze first is the set containing exactly two elements, A and B. And the method that we're going to use for determining the subsets of the set AB is we're going to make what's called a tree diagram. So to make a tree diagram, you want to have a column that asks the question, is A an element of the subset? And a column that asks the question, is B an element of the subset? The answer to each of these questions is either yes or no. So you start by making a little dot and you make two branches under the column of A is an element of the subset. Yes is one possibility, no is another. Now, regardless of whether A is in our subset, B can either be in it or not be in it. So we're going to draw branches coming out from yes, and we're going to say, okay, let's suppose A is in our subset. Then we have two possibilities, either B is or B isn't in our subset. And then let's suppose that A is not in our subset. We still have two possibilities, either B is or B isn't in our subset. This tree diagram is listing all the possible outcomes for constructing subsets of the set we started with. Each branch represents a different outcome. So, for example, working backwards, by the way, reading these tree diagrams is easier in reverse. So, if you want to figure out what scenario this top branch represents, working backwards to the beginning, you see that this branch that terminates here represents the case where both B and A are in the subset. So one subset is the set itself, AB. Now let's use a different color and we're going to look at the next branch. The next branch ends here. Following it back to the beginning, we have that B is not an element of the subset, but A is. So that would be just the subset containing A. This next branch, reading it backwards, starting here, it's going to go through yes and then no. So this represents the scenario that B is in the subset, but A is not. So that's just the subset with just B in it. And then the last branch, well, what do you think that represents? Can anyone tell me what subset we are going to get when you have no and no? Very good, the empty set, that's right. Remember, we learned in the last class that the empty set is actually a subset of all other sets. So we would expect that if we're using this, if I'm telling you that this tree diagram method is a way of listing out all possible subsets, one of the branches should represent the empty set, and it does. So what we see here is that there are four subsets of the set AB. There's the subset which is equal to the original set AB itself. There's the subset containing A, there's the subset that just contains B, and then there's the subset that contains neither one of the elements, the empty set. So if I asked you how many subsets are there of the set AB, you would say there's four subsets. What if I asked you how many proper subsets there are of the set AB? What would you say to that question? How many proper subsets? Very good. There's three proper subsets because remember, proper just means it doesn't equal the original set. So to count the proper subsets is just a matter of eliminating the one that's equal to the original set. So these three down here, those are your proper subsets. They're not equal to the original set. list all the proper subsets of the set 3, 6, 9. So what I'd like you to do is, at home, really quick, jot down what you think are the proper subsets of the set 3, 6, 9. You can use a tree diagram, but you don't have to. You can just try and list them in some organized way. And then I'm going to show you how you can do it using a tree diagram. So at home, you should be trying to list out all the proper subsets of the set 3, 6, 9. I'll give you a clue. Some of the subsets will have 2 elements. Some of the subsets will have 1 element. And then there will be the empty set. It's okay to take a guess. The only thing that's not okay is just to not do anything, because at least if you take a guess, you know if your instincts are correct or not. And then you can work, if they're not correct, you can work towards correcting them. You'll know where you went wrong. But if you just don't even try, then you're not going to know, what your own instincts are and how to correct them. So if I were you at home, I would, if I didn't want to use the tree diagram method, which I understand because tree diagrams look a little overwhelming. There's a reason we're doing them, but I can understand if you don't want to use them. But what you might do is first list all of the subsets that have just 1 element. So for example, there's a subset that contains just 3, the subset that contains just 6, and the subset that contains just 9. And then list all the ones that have 2 elements. So there's the one with 3 and 6, there's the one with 3 and 9, there's the one with 6 and 9. Now, I'm not going to list 9 and 3, for example, because remember the order in which these elements are listed does not matter. So that would be all of the ones that have 2 elements, and the only thing I'm missing now is the empty set. Remember, the subset that's equal to the original set, we don't want that because we're looking for proper subsets. All right, so now let me show you how you would do this with a tree diagram. So what you would do is you'd make 3 columns. One column would represent the question, is 3 an element of the subset? Another column would represent the question, is 6 an element of the subset? And another one would represent, is 9 an element of the subset? Okay, for each question, there's 2 possible answers. We're going to start with the first question, is 3 in the subset? So there's 2 possibilities. Either yes, we are including 3, or no, we're not. Then we look at 6. Regardless of whether 3 was in the subset or not, we still have 2 possibilities. So suppose that 3 was in the subset, then we could either have had 6 in there or 6 not in there. And if 3 was not in the subset, we also have either 6 is or 6 is not. So this brings us up to 4 different possibilities so far. And now we're going to answer the question, is 9 in the subset? Each one of these branches is a different scenario, and in each case we still could have 9 or not 9 in the subset. So yes, no, yes, no, yes, no, yes, no. Each one of these branches represents one scenario. Okay, the first branch represents the scenario where we're including all 3. If you don't see that, let me highlight it for you. Oops. Right, working backwards from the tip of the branch, following along, there's only one path you can take. And that path hits yes, 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 which means that all 3 of the elements are in the subset, 3, 6, 9. All right, now the next branch, who can tell me what subset the next branch represents? That would be the branch, let me get a different highlighter color here. That would be the branch ending here. Following it back, it would go no, yes, yes. Which subset, what elements are in that subset in yellow? You see the branch in yellow that goes through yes, yes, and no? Which elements are in that subset represented by that branch? Three and six, good. Okay, how about the next branch? Let's highlight this one in green here. This one has yes, no, yes. Yes, no, yes. Remember, look at the, look above the branch to see what it's supposed to be including. What's going on here? Come on. Okay, so look above this yes, that's saying that 3 is in the subset. Look above this no, that's saying 6 is not in the subset. Look above this yes, that's saying that 9 is in the subset. So good, Gabby and Olivia and Tanya, yeah. Gabby and Olivia and Tanya, you got 3 and 9, that's correct. Okay, how about give yourself a minute, those of you who have not done so already. I want you to look through these branches and jot down which of these subsets are represented by each of the branches. Okay, so there's 1, 2, 3, 4, 5 branches left that we haven't matched up with a subset. So jot down what each of those you think it is. Okay, do you have something written down? Remember, take a guess. If you're not sure, just see what what your instincts are. All right, so the next branch that ends in no there has a yes and 2 no's. So that one is the one containing 3. The next branch that ends in yes here has a no and 2 yeses. So that's the one containing 6 and 9. The next one, just 6, right? That's the one with the no, yes, no. And the next one, yes, no, no, in reverse order, contains just the 9. And then the no, no, no is the empty set. Okay? So that's how you get these subsets using a tree diagram. Now the tree diagram gives you all the subsets. We only wanted the proper subsets. So our proper subsets are the ones that are not equal to the original set. All right, so there are 7 proper subsets and there are 8 subsets altogether. Some questions will ask you to actually list the subsets or the proper subsets. Other questions will just ask you how many there are. So one of the reasons why we're looking at tree diagrams is so that we can start to see a pattern. Let me go back. And the pattern is that if you're always going to make a column for each one of the elements, then the number of elements is the number of columns. And each column has 2 possibilities, yes or no. So the first element we will always have 2 branches for. When we add in a second element, that doubles the number of branches, so we now have 4 branches. When we have a third element, then that doubles the 4, which brings us up to 8 branches. So that means that we have a pattern here that we can observe that it really doesn't matter what these elements are, 3, 6, and 9, A, B, and C, but the number of elements is going to determine how many subsets we have. The number of branches in this last column is going to be the number of elements. So when we have 3 elements, we have 2 times 2 times 2 equals 8 total subsets. You end up multiplying 2 times itself the same number of times as elements of the set. Okay, so if I asked you to create a tree diagram to list the subsets of this set, which by the way, drawing a tree diagram is a skill I would like you to have, and it does take some practice, so you have to be practicing this on paper. If I asked you to create a tree diagram for this, how many branches would you expect your tree diagram to have? Well, there are 4 elements, which means you would have 4 columns. And for each of the columns, it's going to double the number of branches. So the first column would be 2, the second column would double that, the third column would double that, and the fourth column would double that. Another way of writing this is 2 to the 4th power. And 2 to the 4th power is 16. So we would expect to have 16 branches on our tree diagram, and that corresponds to 16 subsets. So here's what that turns out to look like. Okay, we have the 4 columns asking if A, B, C, and D are in the subset. In each case, we have a yes or a no possibility. So notice that in the first column, we have 2 branches. That doubles for the next column, that's 4 branches, which doubles for the next column, that's 8 branches, and that doubles again for the 4th column, which is going to be 16 branches. So that's going to be 16 different subsets. Each one of these branches, if you work backwards, is going to represent one of the subsets. So the top one's A, B, C, D. The next one is just A, B, and C, and not D. The next one leaves out C. It's got an A, a B, not a C, and then a D. The next one has 2 yeses and 2 nos, so A and B are in, but C and D are out, and so on. And you can identify with each branch which of the elements it's including, and you get every single possible outcome, all 16 of the subsets. And how many of these are proper subsets? How many proper subsets are there of the set A, B, C, D? Or any 4-element set for that matter. Here we go. Okay, so you take the number of subsets, which is 16, and you subtract 1, and you get the number of proper subsets, 15 proper subsets. The only one that's not considered to be a proper subset is the subset that's equal to it, the original set itself. Notice that each element doubled the number of branches in the diagram. 2 times 2 times 2 times 2 equals 16. That's really 2 to the 4th power. 2 to the power of the number of elements. So we have a formula. Anytime you're asked not to actually construct the subsets, but if I just ask you how many of them there are, if you have n elements in your set, you're going to raise 2 to that power. So for example, if I look at the set containing A, B, and C, and I want to know how many subsets there are, I would say 2 to the 3rd power because there's 3 elements in the set, and that would be 8. If I wanted to know the proper subsets, however, we have to leave off the subset that's equal to the original set. So you have to subtract 1 from that. 2 to the 3rd minus 1 is 8 minus 1, which is 7. So this is how you calculate the number of subsets and the number of proper subsets. So I might ask you, find the number of subsets and the number of proper subsets of the set M-A-T-H-Y, mathy. All right, so what do you think? How many subsets of this set? So to answer the question, how many subsets of this set, you have to focus in on the number of elements or the cardinality of the set. So how many elements are in the set? The number of elements in the set mathy is going to be 1, 2, 3, 4, 5. 5 elements. So yes, Alexandra got it. you have to say 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Or you can use the x to the y function on your calculator, raise 2 to the, or actually if you're using the TI-30X2S, it's a little caret symbol, 2 to the 5th power on your calculator, and you should get 32. So there are 5 elements in the set, but the number of subsets is 32. So there are 32 subsets. How many proper subsets are there?